नमस्ते बच्चों, हमेशा खुश रहो. Myself JVn Dr Monika Trivedi. Today I am going to teach you GibbsHelmholtz Equation. Okay. This topic belongs to Thermodynamics, Equilibrium and Solution of B.Sc, B.Ed, PCM, ZBC and B.Sc, PCM, ZBC 4th semester. So the equation Gibbs-Helmholtz equation as was derived by J.W. Gibbs and H. Helmholtz. This expression is for a change in free energy, which is del G, and change in enthalpy, which is del H, while the other expression is a change in internal energy, which is del E, and work function del A. So we have to learn about two equation for the Gibbs-Helmholtz equation. So for a first equation in term of the free energy, and second is for in term of the work function, which is del A. Okay, so first we take the term of a free energy of a and the enthalpy. Okay, so as we know, del G is equals to VdP minus SdT, change in free energy. So at a constant pressure, dP is equals to 0. For this equation, if we put the dP is equals to 0, what we get? The term VdP is a 0. So what we get? Del G is equals to minus SdT. Now let G1 is the initial free energy at temperature T. So the G1 plus dGV be the free energy at the temperature T plus dT. Then what we get? dG1 is equals to minus S1 dt. This is the equation 1, where S1 is the entropy of a system in an initial state. Now suppose the free energy of a system in a final state, which is a G2 at temperature T, and G2 plus dG2 is the free energy at temperature T plus dt in a final state. Then what is a free energy? dG2 is equals to minus S2 dt. This is the equation second, where S2 is the entropy of the system in the final state. By subtracting equation 1 from what we get? We get dG2 minus dG1 is equals to minus S2 minus H1 S1 dt. Okay, as we know, G2 minus G1 is a change in free energy, and S2 minus S1 is change in entropy. So we get d del G is equals to minus del S dt. Okay, at constant pressure, we simplify this equation. At constant pressure we get d del G by dt at constant pressure is equals to minus del S. As we know, del G is equals to del H minus del T del S. Okay, change in Gibbs energy. Okay, so if we calculate the value of minus del S from this equation, so what we get? We get minus del S is equals to del G minus del H divided by T. By comparing the equation 3rd and equation 4, if we compare both the equation, what we get? Del G minus del H by T is equals to d del G by dt at constant pressure P. Okay, or if we simplify this equation, what we get? Del G is equals to del H plus Td, del G by del T at constant pressure. This equation is called Gibbs-Helmholtz equation in term of free energy and enthalpy change at constant pressure. The second expression is for the internal energy and work function. So A is work function here. So as we know, the A is equals to E minus Ts. Okay, or we can write it as a del A, change in work, and is equals to del E, change in internal energy, minus T del S, change in enthalpy. So what we get? Minus del S is equals to A minus del E by T. If we differentiate equation 1, what we get? dA is equals to dE minus T ds minus STD. Okay, so we differentiate both the term T and S, so we get TdS minus STd. For first term we differentiate T in respect to S, and second term we differentiate S respect to T. So for the first law of thermodynamics, dq is equals to dE plus pdV, as we all know. So at the constant volume, del V is equals to 0, so the equation changes like dq is equals to dE. For the reversible change, ds is equals to dq by t, so dq is equals to tds minus de. Comparing the equation third and equation 4, what we get, dA is equals to minus S dt. Let A be the work function in its initial state at temperature T, and the A1 plus dA1 the work function in an initial state at temperature T plus dt, and A2 be the work function in the final state at the temperature T, and A2 plus dA2 with the work function is the final state at the temperature T plus dt. Then what we get, dA1 is equals to minus S1 dt, and dA2 is equals to minus S2 dt, where S1 and S2 are the entropies of the system and initial and final state of the system respectively. Subtracting the equation 5 from the equation 6, what we get, dA2 minus dA1 is equals to minus S2 minus S1 dt. Okay, we know the A2 minus A1 is change in work function, and S2 minus S1 is change in entropy. So what we get here, d del A is equals to minus del S dt at constant volume. d A del A by dt at constant volume is equals to minus del S. From equation second, we have del A minus del E by T is equals to minus del S. On comparing, we have del A minus del E by T equals to d del A T dt at constant volume, and finally we get del A is equals to del E plus Td A del A by dt at constant volume. This equation is called Gibbs-Helmholtz equation in term of internal energy and work function at constant volume. The importance of Gibbs-Helmholtz equation is it is used to calculate the heat of the reaction del H del E when del G or del A at are given temperature. Okay, so this is all about the Gibbs-Helmholtz equation. Thank you very much. This session powered by digital version 2.0 Jayoti Vidyapeeth Women's University. Hope you satisfied with my session. If you have any query, please let me know. Please comment me. Thank you.